Okay, so our next review topic is right triangle trigonometry and special angles. So with right triangle trigonometry, we're always assuming that we're taking our trig function of some angle where the angle is between 0 and 90 degrees, or in radians, pi over 2. So then we can think about, okay, what does that angle look like in a right triangle? Well, if one angle is, say, alpha, well, we know that the total number of angles in the triangle is going to be determined, adds up to 180 degrees, so we can take 180 minus 90 minus alpha, and that gives us the last angle. So 90 degrees minus alpha is the last angle. So we can always think about this angle alpha as really living in some kind of right triangle. So now if we've got three sides here, let's say A, B, and C for the hypotenuse of the triangle, we've got 6 fundamental trig functions. So sine of alpha is equal to the opposite over the hypotenuse, or in other words, A over C. Cosine of alpha is equal to the adjacent over the hypotenuse, or B over C. Now the tangent of alpha, one way to think about it, and this we'll use a lot in calculus, is it's sine of alpha over cosine of alpha. But another way we could think about this is opposite over hypotenuse, or sorry, not hypotenuse, opposite over adjacent, or in the case of this triangle, A over B, and if we were to divide sine by cosine, we would also get A over B after clearing the C's out of the denominator. Cotangent of alpha is cosine of alpha over sine of alpha, adjacent over opposite, or B over A. And then the last two that we have, and let me see if I can keep that triangle there, we've got secant of alpha, which is 1 over the cosine of alpha, and that's equal to, we're flipping cosine, so it'll be hypotenuse over the adjacent, or C over B, in our triangle above. And then finally we have cosecant of alpha, which is 1 over sine alpha, or adjacent, or hypotenuse over opposite, or in the case of this triangle, C over A. So that's our 6 identities. So if we have, for example, a triangle, a 3, 4, 5 triangle, it gives us some alpha. So 3, 4, 5 right triangle, this is not to scale. I know that sine of alpha is 3/5. Cosine of alpha is adjacent over hypotenuse, 4/5. Tangent of alpha is opposite over adjacent, so 3 over 4. Cotangent of alpha is 4 over 3, so I'm just flipping these other fractions. Secant of alpha is 5 over 4, and cosecant of alpha is 5 over 3. So that is kind of right triangle trigonometry for just the basics if you start with a triangle and you know something about its sides. There's also some special triangles that you should have memorized to be a successful calculus student. And these two triangles that I really want to draw this one to scale. So these two triangles, we have a 45, 45, 90 triangle. So in a triangle like this, we can assume that the two sides on the end here are 1, and then using the Pythagorean theorem, since 1 squared plus 1 squared is equal to 2, we get that c squared has to equal the square root of 2. And so if we go through our special formulas, I'm only going to do sine and cosine and tangent here. So we see that sine of 45 degrees, which is the same thing as sine of pi over 4 radians, which is how we'll most often write it, is equal to the opposite over the hypotenuse, so 1 over the square root of 2. I'm okay, and your calc professors will be okay if you write 1 over the square root of 2. You might have seen this in high school by rationalizing the denominator as square root of 2 over 2. Now cosine of pi over 4 is also square root 2 over 2 because the opposite and the adjacent sides are both the same. And the tangent of pi over 4, in this case, these are the same functions, same thing, so we just get 1 over 1 or 1. So that is those three functions, and you can easily figure out what secant, cosecant, and cotangent are after you have those. And the other special triangle is the 30, 60, 90 degree triangle. So the shortest side, which is 1, is opposite the 30 degrees, the 60 degrees, and the 90. So this is 2, and this is the square root of 3. We can find those using properties of triangles and the Pythagorean theorem. So remember that 60 degrees is equal to pi over 3 radians, and 30 degrees is equal to pi over 6 radians. So let's go through 60 degrees first. So sine of pi over 3, that is equal to, all right, so I'm looking at 60 degrees, so opposite, let me do some colors here, opposite over hypotenuse. So undo that highlighting, and we get the square root of 3 for opposite over 2 for the hypotenuse. And then we have cosine of pi over 3 is equal to adjacent over hypotenuse, so that's 1/2. And the tangent of pi over 3 is the opposite over the adjacent, so just the square root of 3. Now we can do the same thing by just so that in that case we chose 60 degrees as our angle, but the same triangle also can give us the sine, cosine, and tangent, and cosecant, all those, for 30 degrees as well. And so that's pi over 6. So sine of pi over 6 is going to be opposite over adjacent, so that's now 1/2. Cosine of pi over 6 is square root 3 over 2. And the tangent of pi over 6 will be 1 over the square root of 3, and if you want to rationalize the denominator, that turns into root 3 over 3. So that's a brief introduction / review for right triangle trigonometry and some special angles. So people have different ways to memorize these special angles. They're really handy if you just know them off the top of your head. And if you remember the form of the triangles and how they always look, then you can figure out these without having to memorize them. So some people will just go in at the start of a test, write down their special triangles, and then they have them to know. But knowing how to convert from radians to degrees will help with that a lot too. All right, if you need extra review with this, please seek out us or the QSC or SI, and we'd be happy to talk more about these right triangles and the special right triangles here. And some of the other videos to follow will go through how we deal with angles that are not between 0 and pi over 2 radians. All right, so I'll sign off here.